our goal is to help people solve their data challenges so they can spend time fighting for their causes rather than fighting their data. As a grant program recipient, you can receive FME Desktop or FME Server licenses. Well, if you're going to get FME Server, you really need FME Desktop because that's the starting point in FME. There's no cost. It is completely free if you are eligible for the grant program, and you also receive the free upgrades of FME training materials, online courses, and all our online support materials are available to you. We do have a dedicated grant program coordinator. That's Moira Seaboom here. So when she's not hopping around obstacles in the forest, she's managing our grant program as our dedicated grant program coordinator. And so she's the one that you'll work with when you do apply for grants. So let's have a look at what type of institutions are using FME in their programs and taking use of a grant program. And so what I'm going to highlight here today is our local technology institute, the British Columbia Institute of Technology. They have a 9-month intense GIS program. They're in the city of Burnaby, which is part of Metro Vancouver here. So BCIT gives a short workshop on using FME to all their students. Actually today that is going on because they are local. We actually go down there and give that workshop as one of their part of one of their courses. Somebody's there today, and then they have the FME installed in their labs, and they do a couple of course projects where they include FME in their projects. And then the students who are working on their own projects, they have access to FME in those labs. The students at BCIT also do a practicum, and so they can use FME for that practicum, and that can be either kind of an industrial practicum if they can get an industrial placement for about 6 weeks, I think the total practicum is. Most of our support team here at SAFE have gone through the BCIT GIS program, mostly after taking a degree that couldn't get them a decent job in the workforce, and so they've gone back to BCIT to get that. And Robin knows that because
I did that too. It's a great program.
And then I'll just add, as a graduation gift, we give all the students a 1-year free FME Desktop license that they can take away with them after they graduate and use at home, or actually they can use in their first job. And we've found that the students have come out of BCIT, have gone to a new job, they've been introduced to FME at BCIT, and they felt that they've been in a job where they could use FME, but of course being low on the totem pole, it's hard for them to convince their management that maybe they should be using FME for a particular job. So we give them a free license so they can actually use that for their first job and convince somebody that FME is a great tool for something to do. And so just a couple of other examples there of people using FME in a similar way. Canberra Institute of Technology, Greg Patterson, big user of FME in his teaching programs. Massachusetts Amherst, Alexander Stepanov is using FME a lot in his teaching, and also Unigis, Joseph Strobel at Unigis is using FME quite a lot in his teaching. So about 200 universities and colleges are taking advantage of our grant program, which is really great, and some of them are just using it in their labs, some of them are using it in their technology kind of area. And then around the non-profit institutions who are using FME, a wide range of uses. So we can just pause for a moment and see if there's any questions have come up about the grant program. If there are any questions as we're going along here, just fire them off into the questions panel. We did have a couple of questions earlier. Somebody said they were a U.S. citizen studying in Germany. Would they still qualify? Yeah, well, they would do if they still actually qualified as a basic student or researcher or non-profit. It doesn't really matter where you're sitting. where your desk is, or what country you're from, we'd be happy to give you an example of the grant program. Okay, so up next what we're going to do is we're going to walk through a few examples of people who have taken advantage of the FME program and have just a quick kind of overview look at their projects to give you an idea of what people are doing kind of in this space of not-for-profit teaching and research.
Yes, so the first story comes out of the Technical University of Munich, and it was a project done by a couple of master's students, Barbara Berger and Berit Katzler, and they are doing a lot of work with the CityGML format in Europe and showing its power as a 3D format for working with urban data. CityGML, many of us in North America haven't heard about it. It's an application-independent geospatial information model for semantic 3D city and landscape models. And that's quite a mouthful, but Thomas Kolbe out of the Technical University of Munich could be known as one of the founding fathers of CityGML, and it was developed through the SIG3D group. And as of 2012, the OGC has adopted CityGML 2.0 as a standard format for working with 3D urban data. So anyone that's involved in doing any of that kind of work, this is a format that's really worth taking a look at. And its strength is that it allows for different thematic layers, such as buildings, traffic. You can do work with tunnels and bridges. You can get that 3D-ness of working with traffic data, for instance. It also can represent both geometry and topology, so it provides for a really rich data model. And then the other nice thing about it is it's open source, so it allows users to share virtual 3D city and landscape models in sophisticated analysis and display tasks, you know, environmental simulations, energy demand estimates, disaster management, all of those kind of things that you might be analyzing around a city. So the Technical University of Munich is a leading provider of these 3D virtual city models through Europe, and they have a very award-winning spatial database that they make use of for the CityGML, and you can find out lots more information about that from their web page out here. So the nice thing about the CityGML, it's been widely used throughout Europe, and the 3D geoinformation standards for Germany and Netherlands are also based on CityGML. But there's not been much implementation in the US yet, so the students' project was to demonstrate how to build a 3D city model for New York City. I mean, start with one of the big cities in an attempt to show how useful this format actually is. So they took a whole lot of data from the New York City data portal. However, it was all just 2D or 2.5D data, and you know, the usual stuff, AutoCAD of the traffic networks and a bunch of building footprints and things like that. And a lot of it wasn't coordinate system aware. You know, the surveyors tend to use their own coordinate systems, or there'd be a bunch of stuff in lat long. So how to get that all, put it into a 3D model. And of course, because they picked New York City, it's a huge area with more than 1 million buildings and a total of about 4 million objects that they had to work with. They were also working with multiple different exchange formats. So this is really where FME comes into its own, because this is an FME problem. So what they ended up doing was putting together a workflow that looked like this. So it had, the implementation was based on the City Geo database that's sitting on Oracle Spatial. They used FME to get that data from all these various bits and pieces and put it into the CityGML format, which then they could use the 3D importer exporter that they've built for their geospatial database, Oracle Geospatial database. And then they could export or export it out to various other formats. And what they use is this Cesium, which is a new virtual globe and map engine that you can use in your own applications. So their use of FME was to get the data into the CityGML and then to maintain it on this Oracle database. So, and what they ended up with was a city of New York that looked like this, and it's a great, great model. So we can just take a quick look at it, and I've got it up here. So this is it live in the model, so you can see as we go in or out, it starts to fill in these 3D buildings. And if you actually click on a building, you can get the attribute values of that building, and so it'll show you what the building was, where it is, and a bunch of other information. Actually, even things like the number of floors in that building, when it was built and when it was altered. So they've done a heck of a lot of work in gathering up all that data. So we also have additional resources for working with 3D data on our webpage if people are interested in that. Keep going. So there's a 3D tutorial on our webpage that you can have a look at that explains a lot about working with this. So the next one I was going to talk about was a non-profit organization that's making use of our grant program. And this is another local non-profit that is the Community Mapping Network. And these guys provide an atlas that they've been maintaining since the year 2000, mapping sensitive habitats and species distributions to help with development processes around the areas. So they're kind of looking after all the sensitive areas in the province when somebody's going to do a building development, because, you know, swamps are not of much interest to developers. They just want to fill them in with houses. So that's why these guys are keeping track of all those kind of areas for us. So they have a really wonderful web page that they keep up to date, and a lot of it's done crowdsourced, or with non-technical people bringing in the data. So what they found was this little database package that you can put on your iPhone or your smartphones, PDAs and things like that, called HandyBase. And they've put that onto smartphones, and then people in the field can collect the data that they want for about a particular area of interest. So what this particular project was about was for wetlands. So their wetland people would go out into the field. This is what the application looked like on their phone. They could fill in some of the pre-filled fields. Now I've taken this slide from Rob Knight's presentation from our user conference, and I noticed he's listening today, so forgive me, Rob, if I've misspoken about anything. But basically the data comes in. Some of the fields can be pre-filled for you, others you put in as you go. And it meant that they could collect the information right from the phone, so GPS coordinates, and it also allowed for much more consistent data collection. So the additional beauty of this was once they got back to a coffee shop or somewhere, because, you know, these are just citizens, they might not have data plans, they can email that data into an email address. So that meant that, again, it wasn't, somebody didn't have to manage it. They could just email to an email address, and this is where their license for FME Server helped them out. Because FME Server could monitor that email address and read in the files that came in from there, and then they were running a little workspace that allowed them to get off who the person was that sent this email in, and then read in the attachment that was attached to it. So that would get them the location of the wetland and any other information that the person had collected. Once they had done that, then it was updating a SQL Server 2012 database, which is the back end for their MapInfo mapping page. So right away, as soon as the email has been received, pretty much the data would be available on their website. And so that's what they'd end up with, something like this. And so the Community Mapping Network Wetlands website shows the full extent of their work, and we'll just take a look here. We can see what it looks like. I've got an example of their wetland here. So this is their map, and these are the wetlands that have been mapped. And if we take a look at this one up here near Prince George, you can see the kind of information that was received from the phone. So it's got this, here are their attributes as they came in, and who did it, and where he's from, and so on. So this was collected in 2014. So by using this application, they've got really good information, and we can even see what that wetland looks like. If we click over to here, and we get an idea of the kind of work they've been doing. So it looks like they manually walk around this thing with their phone getting these polygons, and the information is available.
In waders, I assume.
I would hope so, in waders. Presumably these are shallow wetlands. Okay, so Mark, back to you. What have you got to talk about?
Smart things, smart partnership. And so this is, I think, a really interesting project. So mainly put together by Mark Sondheim, who's with Refractions Research on Vancouver Island here in BC, and also Jonathan Palmer at the Wildlife Conservation Society. And SMART provides timely and accurate information on where poaching and illegal activities like logging are going on that threaten biodiversity and those kind of things. And they have a great website, so if you want to learn more about the SMART program, you can go there. They have actually a somewhat disturbing little movie about why they're in business, because that movie there, which I'm not going to show you now, does discuss what they're doing there. Okay, so we're trying to find the slides. There we go. Okay, so the SMART partnership is a collaboration really of a few major conservation agencies there, and their role is to help protect these endangered species and endangered areas of biodiversity. The SMART tool set is designed to be used in remote locations, often where there is no internet available, where electrical power is not stable. They send out patrols into the parks or nature reserves and wildlife areas to monitor poaching and related illegal activities. The data is collected on the patrols and entered into the SMART. SMART is also used to plan where new patrols should go out, and so they know where sort of poaching activity or illegal logging might be going on, and so they can focus their limited resources on their patrols to get out there. It is underwritten by a consortium of these major conservation organizations. And so as you can see that the FME Grant Program, as these three examples that we've looked at so far, isn't just used for schools. The SMART Partnership is one of the many grant recipients whose efforts we're very, very happy to support. So what's FME's role in this SMART program? FME is playing a supporting role here. So the SMART tools themselves are mostly open source software that the Refractions team pulled together, I believe. But FME's role here really is a sort of a background role where we help them convert the historic data sets into the newer SMART databases. So one of the tasks that the SMART tackled was the conversion of their original data, which was in a Firebird database, and that had to be pulled into the newer Postgres database that they now use. They also use a SMART formatted XML that's the input file for their Derby database that they use in the SMART mobiles, and so FME has helped them create those XML input files as well. Plus using some of the XML transformation tools that are available in FME. So that's kind of like the range of background tools that FME has been using there. One of the issues that we found with working with many of the NGOs and not-for-profits is that there's often a relatively high staff turnover at these organizations, and so using technical products like FME or any of the other GIS products is a problem for them because they have to keep retraining staff, and so we really encourage any of the not-for-profits to make use of our online resources, particularly our free online training sessions that we always have. We'll talk about that in a little while, how people can get onto our online training, but that's certainly something that we would like to help with if organizations do have higher staff turnover than most of the other commercial outfits that we work with, where staff are a bit more stable, and we can certainly help them there. Okay, next up, we're going to just put together a little summary of some work that Ryan Kelly did using our grant program. And again, I noticed that Ryan is online here, so I hope he's not going to be too insulted by us butchering his presentation here. That he gave at some point. So Ryan was doing his master's at Johns Hopkins University. It's actually the Zanvar Krieger School of Arts and Sciences at Johns Hopkins University. That's where he was getting his master's from. Ryan has now completed that, and he's now working at the NOAA Met Lab. And so as part of his master's program, what he wanted to do is put together a project and build a proof of concept with a flexible architecture to support multi-dimensional formats, which are complex formats used kind of in weather and atmospheric research, like NetCDF, GRIB, and HDF. And really, he thought that he could put together, as an example, this architecture that would make these complex data sets more accessible to researchers in this field who maybe don't have the technology or the technical skills to access the data in these more complex data sets. So that there on the right-hand side there is just a kind of a summary of the architecture he was putting together. So there is a service for distributing this type of data. It's an open source service called THREDDS, the Thematic Real-Time Environmental Distributed Data Services. And so THREDDS is really a catalog of these multi-dimensional data sets that are out there, and gigabytes of this stuff floating around, that's for sure. And so Ryan's goal was to integrate the THREDDS services into an FME-powered workflow, which would more openly distribute the data to a wider audience and simplify the data a bit. As a secondary goal, Ryan wanted to sort of experiment and illustrate the use of a traditional relational database within this kind of type of data, and how traditional SQL could be maybe leveraged to do some of the data analysis rather than building customized scripts and sort of little programs. So he did. So the work was basically in two kind of stages. One was to take the data out of the THREDDS service from these more complex formats like NetCDF and publish them up into a PostGIS database. And then the second process was to allow users to extract the data from the PostGIS into a wide variety of mostly raster formats that could be more easily consumed by the average researcher. So we've got the workspace, one of his workspaces there that we can just have a quick poke around in. There we go. And you can see here this was mainly the raster processing tools he put together. And you can see at the top there a few of the raster kind of transformation tools that we've got in there. The raster bands separator, so splitting out the bands from more complex rasters into simplifying those, testing and filtering out bands that he doesn't want to work with, removing no data from the data sets, and then the raster cell coercer swaps the kind of cell format depending on the what kind of data structure there is within the individual data sets that you're working with. So a lot of good, strong raster tools within FME, and you can see that largely this workflow is converting the NetCDF from into the Postgres database. And there, Robin's brought up there a few of the examples of the wide range of raster transformation tools that we've got in FME. Okay. Yep. Yeah, I should mention there that once he built these workflows, all those workflows were put up on FME Server, sort of so that they could be automated a little bit more. So that his project was a combination of building the FME desktop workflows and also putting together an FME server environment where it was more accessible to people from web pages. And then here we've got is a few examples of the kind of data outputs that he was generating, a glimpse of some of these outputs that he's got. He was experimenting with using SQL for data analysis of this kind of data. So on the bottom left there, you can see a chart, a histogram chart that he generated out of the post, just using SQL to create a histogram of humidity ranges in this particular case. And then the images there across the blue one there, wind magnitudes, for he could generate those for various pixel resolutions. And the green one there, relative humidity. The blue and red one there are the surface temperatures. And then on the right-hand side are moving GIF images, again with different resolutions of the grid from different source data sets. So he was, able to build up examples where you could compare different sources of data and those outputs and see how they compared for the same predictions. Ryan also produced a really comprehensive report on this whole project as part of his master's program, which is very impressive as well. So anyway, that's just more of a kind of a researchy type project that somebody put together with the FME tools as part of the master's program. So thanks, Ryan, for sharing that with us.
Right, and we couldn't do one of these webinars without talking about Minecraft. And there's been a lot of talk about Minecraft around the SAFE headquarters, and some of us that aren't into gaming couldn't quite see what the point of that all was. But this example certainly started to make it all make sense. And so thank you to Darren Platakis, who's also online today, for this example of using Minecraft as an educational tool. So there were some students at Niagara College's GIS management program that were looking to work on a year-long thesis project, collaborating with real employers to design and implement a real-world GIS project. And so this year, one of those projects was put forth by Geospatial Niagara, courtesy of Darren, and he'd seen various Minecraft initiatives going on around the world and thought that it might be a great potential as an educational tool. And of course, with one of the world's most recognizable features nearby, why not try and map the region and turn the famous Niagara Falls into a Minecraft world? So this example is really interesting because it's a great way to engage kids in geography and allow them to go out there into the world they're familiar with through the gaming and build and enhance real-life worlds or whatever it is you do in Minecraft. So once you've got these kids to put this thing together, how are they going to share it? And so the next steps were making it available to teachers via something called iHub, which is in Ontario or in the Niagara region, and it's a collaboration between the education department and technology companies like this to integrate these kind of ideas into the curriculum. So once they've done Niagara Falls, which you can see here in the corner is all blockerized as using these kind of Minecraft block things that make it easy to work with. He's going to get another group to come in and go underground to try and incorporate the geology of underlying this area, and then that will allow students to dig underground and see how that all works. And what a great way of teaching geology and engineering concepts and spatial reasoning to children. And so I actually could see the sense of Minecraft after all. So, and it turns out there's lots of this sort of stuff happening around the world, and so the Norwegians have got a great example of it, and one of our blog postings of what they were doing in Norway is available on our website, and there they were having kids build Minecraft worlds and then letting them actually print them on 3D printers, so they got into the whole 3D modeling environment, and that system is also up on the web. You can go to Norway and find a map of Norway and pick bits and pieces of it out and turn it into Minecraft worlds. In addition, the other one is that we have put together a webinar so this is great for kids, but how do we bring this into an adult kind of world, and what uses of it is it to those of us that work in the GIS industry? So a webinar that we did earlier on Minecraft is available on the website, And there we talk about some of the scenarios that you might be interested in putting something like this together. So, and again, these are all great theses for educational programs. So you can turn something into Minecraft using your GIS data, so going from Shape or AutoCAD, something like that. And then you can work on kind of natural and urban scenarios, things like what if the sea level rises or falls by 100 meters, or how quickly can a forest fire spread and what are the consequences, or what if the sleeping volcano suddenly erupted. So taking a look at a workspace that might be working with Minecraft, this is what we've got here. So here we're bringing in some vegetation information, which I've got displayed here. So this is a picture of Bowen Island, which is just off the coast of Vancouver, and it has a bunch of polygons. This is a MyTab file, MapInfo tab file, and so there's a bunch of canopy polygons that they've done here. So this one here is a deciduous tree, and they've got another polygon here of deciduous trees, and one over here of coniferous forest, that sort of stuff. So they mapped the vegetation of the whole island, and then this particular workspace can take it all into Minecraft blocks. So
and it looks like they're overlaying on
a digital, that's right, a digital elevation model of the island. So that gives them the 3D effect that they needed. And so again, looking at the different kinds of transformers that FME gives to you for working with data, we can do reprojecting things into correct coordinate systems. We can dissolve areas and buffer data and clip things into different sizes and by different areas. And then someone had put together a whole lot of these little transformers that allow us to style Minecraft oak trees, coniferous trees, birch trees, dandelions, and so on.
I think this is Dimitri by
Yes.
his work here, isn't
Yeah.
it?
So the fellow,
Dimitri's in our office here, specializing in Minecraft games.
That's right. And so Dimitri is the guy who looks like this, and he did this wonderful geospatial in Minecraft, Why You Should Care. So certainly the Niagara region opened our eyes to what could be done in terms of getting this stuff going, and then of course it expands out into the world. So okay, and also you can use Minecraft as a simple interactive viewer for building information data. So if you've got a BIM data and you haven't got an AutoCAD or one of those big expensive software products, turn it into Minecraft and you can get inside the building and take a look at it.
Yeah, it is definitely becoming an interesting tool, I guess, for community engagement. We've heard of people who are using the Minecraft, I don't know whether you call it a scripting or programming language, so you can program objects and their behaviors, and they're using that to teach kids programming at quite an early age because they get a really visual representation of the work that they did. And also for community engagement, I think block home, is it what they call it in Scandinavia? So where they've taken the street layouts of cities and then allow people to rebuild the city from their perspective. And actually I think that's where our initiative for adding Minecraft support came to FME. Was one of our resellers there, Off Manson, thought we should be able to help with these block home projects that have been used in various Scandinavian cities, I think now, for community engagement in city planning as well. So quite a wide range of tools.
So I kind of think the kids at Niagara College will be lining up next year for Darren's next year's project to get this stuff into geology.
Yes,
so
that's right.
It would seem to me it'll be a popular thesis topic from now on. Okay. So that's our 5 stories, and so now Mark's going to tell you how you can apply for it.
Yeah. So can we just go to our safe.com website? So it's quite easy to apply. You go to our website, then you have to find out where to get that grant program. So it's under About, and there you'll see down there the grant program menu, and then you just say whether you're a student or instructor, and then lower down there you'll see that you just fill out a very simple form and give us a description of what you're trying to do with FME. And then if Moira is not riding her bike around her cabin in northern BC, she will look at your application and start organizing how to get a license. So that's a very simple process for getting your application for the grant program back in. Okay, so that's how to apply. You get eligible for free FME Desktop and FME Server licenses, as we've said, for research education, and we should say not-for-profit organizations as well. Have a look at those applications on our website. If you've got any other questions around there, you can use our online chat to ask our front-end support team questions about how you can get going with that. And as I mentioned earlier on, particularly for the NGOs, but also for students, if they're interested, we do run regular FME Desktop training sessions, usually at least once a month, and actually we have one continuing today, focused around location intelligence. And so have a look at our online training schedule. Those materials are also available as on-demand training, so if you want to do it at your own pace. There's also tutorials which are just sort of shorter and sharper, but we do recommend taking the time to do our basic training if you do have the time. 2 mornings, 4 hours each, really give you a good in-depth understanding of how to use the Workbench tool, which is key to getting going with FME. And then we also have ad hoc courses on FME server authoring. We just gave one on working with the Small World database and so on. So have a look at safe.com training and make use of those materials there.
Yeah, even master students, etc., would be interested in that kind of thing. You know, being able to just pick out the bits. And we just got a word from Darren that yes, he does have 2 students starting the geology project this year, and that's great stuff.
That's great, yeah. So that's exciting, absolutely, totally exciting there. We'll have next year, Darren will be expecting to see a report on the progress of your geology.
Yep. Because Mark, with his geology background, could be the advisor.
Yeah, I'm a mining engineer, but we also have actually a real geologist here, Rylan, who just joined us from the BCIT GIS program.
Yeah. Great. So what else do we have here? That's just about it. Yep. So
yeah. So not too many questions popped up there. I don't think so.
No, it sounds like somebody else is doing underground geology for a Minecraft project in St. Louis. So that's rather interesting. We need to put you in touch with one another.
Okay, so with that, I think that wraps up our very short introduction to our grant program. Hopefully many more of you can take advantage of that or continue to use it and possibly expand its role. If you want to expand the role in your teaching of FME, of your GIS program using FME in your projects or your classes, just let us know. We can give you some of the materials that we have in our training materials ourselves, and we're happy to share those with you. Okay, so with that, it's goodbye from me.
And it's goodbye from him.
And thanks a lot for joining us today, and happy FME transformations if you do take advantage of that.
Yeah.
Okay, thanks a lot.